Okay, we are going to look at 3 more theorems in this video, and they are a converse to the theorems that you looked at in the last video. So the last video talked about how if we have a right triangle, then the side lengths fit into the Pythagorean theorem, a squared plus b squared equals c squared. The converse of that would be that if the side lengths fit into a squared plus b squared plus c squared equals c squared, then we have a right triangle. So it gives us a way to prove whether or not we have a right triangle. So go ahead and get theorem 9.5 down into your notes. The second 2 theorems go together, and the abbreviated version of those is 9.6 says that if we have a squared plus b squared greater than c squared, or if you want to look at that as c squared is less than, then we have an acute triangle. If c squared turns out to be greater than a squared plus b squared, then we have an obtuse. So I always just remember c squared greater, then I have greater than 90 or obtuse, c squared less than, I have acute. So let's look at these triangles and determine whether or not they are right triangles or if they are acute or obtuse. So we set it up as if we are going to solve in the Pythagorean theorem. So 7 squared plus 10 squared. Now I'm not going by the angle here or the fact that it looks like a right angle. I'm going by the shortest 2 sides have to be the legs. So they have to be A and B. So always look for the 2 shortest sides to plug in for A and B. And then I don't know what's going to go here. Is it an equals or is it a less than or greater than? So I'm going to leave that blank. And then I have 13.4 squared. So I go ahead and solve this out, simplify. So I have 149 on the left. Still don't know what goes in that blank. And 13.4 squared is 179.56. So you can see that c squared is greater than a squared plus b squared, so that is obtuse. To check the second triangle, I have 6 squared plus 12 squared, the 2 shortest sides, and I have 6 square root of 5 squared. So in the last video we had this situation, so we knew that was 36 times 5. We know that's 180. The left side is 36 plus 144, which is also 180. So those are equal. So we have a right triangle. On example 2, we want to first make sure we have a triangle in the first place because we don't have a diagram here, so we're not even sure these numbers work. So if you remember back a couple chapters, we had a theorem that talked about whether or not sides could even form a triangle, and we said that the 2 shortest sides had to be greater than the third side in order to form a triangle. So if I check A, let's just do that work up here, I have 8 plus 18, and that is 26, so that is greater than 24. So this one is okay. And let's just check B while we're at it. So 3.2 plus 4.8, that is also greater than 5.1. Again, these are the 2 smaller sides that I checked first, that I add together, and it has to be greater than the third. So this is 8 greater than 5.1. So this one's also okay. So both of those are triangles, so let's just check to see whether they're right, acute, or obtuse. So take the 2 shorter, 8 squared plus 18 squared, and we don't know what goes there, and 24 squared. So 64 plus 324, and 24 squared is 576. Add these together, I get 388, and that is obviously less than 576, so c squared is greater, so this is obtuse. Checking question B, 3.2 squared plus 4.8 squared and 5.1 squared. The left side, it turns out to be 33.28. Just do that on your calculator. And the right side is 26.01. So in this case, c squared is less than a squared plus b squared, so this is acute. And that's all there is to it. Example 3. If we measure 4 walls of a room and we have 9 by 9 by 40 by 40, does this prove that the room is rectangular? Well, let's look. If we have 9 and 9 this way, that's not a rectangle. That would actually be a kite. If we have this way, where the opposite sides are congruent, then really what we have here is a parallelogram, but not necessarily a rectangle. All right, so let's assume for a minute that this is the scenario we have, that it's 9 by 40 room, because this would be a little bit strange. And so we do have a parallelogram that's 9 by 40, but we do not have that it's a rectangle. So here's your problem to bring to class tomorrow. You measure the diagonal of the room that we just talked about, that was 9 by 40, to be 41 feet. How does this help you prove that the room is rectangular? So that'll be your extra credit problem for tomorrow. Don't forget that we have a quiz, and it will include some of this material. So quiz on Tuesday, and that will be over 9.1 to 9.3.